Hello again. These will be the video notes for 10.5 completing the square. There is a PDF available if you want to print it out and follow along. We are going to go kind of quick through this. First thing about completing the square is its two primary purposes are finding square roots of a quadratic relationship, and we typically use this when the quadratic is unfactorable. It can be done when it is factorable, but most of the time it's because it's not factorable we use this technique. Number two, determining the vertex of a parabola. And if we know where the vertex is located on the parabola, we can then tell what the min or max value of the function is. If you didn't watch the video on perfect square trinomials or squaring of binomials and learning that pattern, you want to go back and watch it. That was in chapter 9. But we have to understand where the perfect square trinomial is. So if I have an n plus 6 squared, that produces the pattern of n to the second power plus 2 times n times 6 plus 6 to the second power, and that's our shortcut. So we end up getting n squared plus 12n plus 36, and this right here is what's known as a perfect square trinomial. So when we're doing completing the square, we're trying to force the equation to equal a perfect square trinomial. The reason for that is we can quickly factor that back into the square of a binomial, which is n plus 6 to the second power. We have another pattern down here where we have a minus in between instead of a plus, and that fits a very similar pattern. So we have an n to the second power minus 2 times n times 6 plus 6 to the second power. So when we simplify that, we get n squared minus 12n plus 36. And this also is a perfect square trinomial. And one of the things you'll notice about the middle number we get here on both of these scenarios is that number is found by taking the n times the negative 6, so we get negative 6n, and then doubling it, times it by 2. So that's why we have a times 2 here. That's how we know this pattern will work, and we can multiply it out or factor it back out very quickly. What we're trying to do is to force a perfect square trinomial in the problem. Now we have to remember standard form, ax squared plus bx plus c. So what we're going to be focusing on is the b value and forcing a c value that allows us to have a perfect square trinomial. Now normally we have to have a leading coefficient of 1, and we will have some examples where we don't have that, and we'll show you how to deal with that when we get there. So what we're trying to figure out is what value of c can I place here to form a perfect square trinomial out of that expression. Well, what we're going to do is we're going to take the b value, which is always the middle term here, divide it by 2, and then square it, and that's what we put in place of c. So over here we have an 8 over 2 squared. So 8 over 2 is 4. 4 squared is 16. So what we're going to do is add a 16. So we have an x squared plus 8x plus 16. That is a perfect square trinomial. Now one of the other things we're going to want to do is write it as the square of a binomial. So we're going to fit it to this pattern. So in order to do that, we're just going to take the square root of x squared, which is x, and the square root of 16, which is 4. Then we look at our middle term. It's got a positive sign, so we're going to put a plus there. And if we want to make sure that we did it right, we will multiply these together, 4x times it by 2, and see that we get that number back again. If we do, then we know we did that right. So we're going to start off with something that looks like this, try to figure out this, and then turn it into the square of a binomial, and that's how we're going to start using completing the square. Next example here, we're going to take the negative 12, take half of it, and then raise it to the second power. Well, negative 12 divided by 2 is negative 6, and negative 6 squared is going to give us 36. So we're going to rewrite that as x squared minus 12x plus 36. This is our perfect square trinomial. Now we're going to write it into the pattern that fits the square of a binomial. So we're going to take the square root of the first term, that will give us x, square root of the last term, that will give us 6, and the middle term carries a negative, so we're going to put a minus in between it. So we have an x minus 6 squared. Same thing down here. The only difference is instead of having a nice even number, we have a odd number, that which when divided out would give us a nice decimal, but for right now we're just going to leave it as a fraction. We're still going to square it, so it's 3 over 2 squared, and we're going to call that 9 over 4. So we're going to write that as x squared plus 3x plus 9 over 4. Now that's our perfect square trinomial, and we want to put it back into square of a binomial. So we're going to take the square root of the first term, and we get x. Square root of the last term, that puts us back at 3 over 2. And the middle term carries a positive, and that's going to be our plus. All right, so now it's time to put it into action. Example 1, solving using completing the square. Write a little space after my second term here, put my equal sign, and a minus 15. And then I got to figure out what do I have to add here to turn that into a perfect square trinomial. Remember, that's going to be half of the middle term, which is negative 16, and then square it. So that's negative 8. Negative 8 squared is positive 64. And one thing you have to keep in mind is if I add 64 to the left-hand side of my problem, I have to add 64 to my right-hand side of the problem. Go ahead and continue to simplify. The right-hand side is going to become 49. The left-hand side I'm going to rewrite as the square of a binomial. So take the square root of the first one, and we get x, square root of the last one, and we get 8, and we carry a negative sign down. So now we have 8x minus 8 squared is equal to 49. Well, if you remember back to Pythagorean theorem, when we had things like a squared equals something, to get rid of the square, we would take the square root of both sides. So that's all we're going to do right now. We're going to take the square root of this side, and we're going to take the square root of that side. So when I take the square root of x minus 8 squared, all that's left over is x minus 8. And that's going to equal, now keep in mind also that when you take the square root of a number, there's always a positive and a negative square root. So the square root of 49 is actually equal to positive 7, but it's also equal to negative 7. So we're going to end up with two answers here, as we expect we would with a quadratic. Remember, this is a power 2, which makes it quadratic. So in the first one, we can have an x equal to 7 plus 8, which would give us 15. On the second one, we can have an x equal to negative 7 plus 8, which would give us positive 1. So we have two possible roots of 15 and 1. Now we did say that we could put this into vertex form. And vertex form has to do with this level right here before we took the square root. So what I'm going to do is I'm going to rewrite that as x minus 8 squared, and I'm going to bring the 49 over with it, so I'm going to put minus 49 and force the whole thing to equal 0. So all we did was take this 49 and move it to that side of the problem. Once you have it in this form, the vertex of our parabola is simply the x comes from this value, the y comes from this value. So the opposite of what you see here is actually an 8. So our x coordinate is 8, and our y coordinate would be negative 49. So the vertex will be located at 8, negative 49. And since we know this is a minimum function because the leading coefficient out here was a positive, the minimum of this function would be negative 49. Now all other values would be bigger than that. Example 2, we're still using completing the square. However, this is slightly different because you'll see that our leading coefficient is not a 1. Not a problem. First thing I'm going to do is take this minus 8 and move it over here. Now that's a step you don't have to do, but it's highly recommended that you do that. What's left over is a 2 and a 20x. But what I want to do is turn this into a 1. So all I got to do is factor a 2 out of both of those terms. So I'm going to write 2 on the outside, x squared plus 10x. I'm going to leave a little space because I want to complete the square, equal to 8. So what is it I got to put inside here? What do I have to add to turn this into a perfect square trinomial? Well, we're going to take the middle term of 10, divide it by 2, and square it. So 10 divided by 2 is 5. 5 squared is 25. So we're going to add 25. Now we added 25 inside the parentheses, but you'll notice there was a times 2 on the outside. So what I really did was add 50 to the problem. So I don't add 25 on the right hand side, I have to actually add 50. If I were to multiply this out, distribute this out, that 25 would actually turn into a 50, so I have to add 50 to the other side instead. Okay, so simplify. For here I have 58, and over here I have 2 times, and in parentheses, square root of x squared is x, square root of 25 is 5, plus sign in between. So I have 2 times x plus 5 squared equal to 58. If I want to solve this, I got to first get rid of my 2. So I'm going to divide by 2 on both sides because I can't take the square root until the square root's isolated. So I have 58 divided by 2, and that's going to give me a 29. So I have an x plus 5 squared, that's a 5, is equal to 29. And now I can take the square root of both sides. So I'll have an x plus 5 equal to, now this 29 is not a perfect square, so I'm going to have to round that. So when I take the square root of that, I'm going to estimate it to 2 decimal places, so I'm going to call it 5.39. 5.39. And I'm going to also write the x plus 5 equal to a negative 5.39. Solve for x, subtract 5 from both sides, and x equals 0.39. Subtract 5 from both sides, and x is going to equal negative 10.39. Example number 3, again, I do not have a leading coefficient that is 1, so I'm going to have to turn it into a 1, but the first thing I'm going to do is get rid of my negative 9, move it to the other side, so I have a 3x squared plus 8x is equal to a positive 9. Now I want to factor out of here a 3, so I'm basically dividing a 3 out. So I'm going to bring my 3 outside, call this an x squared, plus, now since 8 divided by 3 will give me a repeating decimal, instead of actually dividing it out to a decimal, I'm going to leave it as 8 over 3x. So I'm just going to leave it as a fraction, 8 over 3. Okay, leave a space, put my 9 in there. Now I got to figure out what do I have to add here to turn that into a perfect square trinomial. Remember, we're going to take 8/3, take half of it, which is really timesing it by 1/2, and then squaring it. Well, 8/3 times a half is actually 4/3, and then I'm going to square it. So 4/3 squared will give us 16 over 9. Now on the other side I have to add, but I'm not adding 16 over 9. Remember, I had a times 3 on the outside. So the effect there isn't really 16/9, it's really 3 times 16/9. So what do we need to do is take our 3 times it by 16 over 9 and simplify that, and we see we actually get 16/3. So I'm going to add 16/3 to the other side. Go ahead and simplify this. I have a square root of x squared, which is x, the square root of 16/9, which is 4/3, plus sign in between, and 9 plus 16/3. I'm going to go ahead and convert that to, that's actually 9 and 16/3, but what I'm going to do is I'm going to convert that to an improper fraction, 43/3. So I'm going to leave it as a fraction. Now to get rid of my 3 on the outside here, before I can take care of my square root, I'm going to times by the reciprocal, which is 1/3. So I'm going to times this side by 1/3 also. These will cancel out, leaving x plus 4/3 squared equal to 43/9. Use your calculator in this next step. We're going to take the square root of both sides. So all we have is x plus 4/3 equals, and I'm going to have to write it twice, x plus 4/3 equals. Use your calculator to determine the square root of 43/9. So square root 43 divided by 9 gives me about 2.19. So 2.19 and negative 2.19. At this point, since we're rounding our answers, I'm going to go ahead and take that 4/3 and put it into a decimal. So 4 divided by 3 is going to give me about 1.33. And this one's going to be a 1.33 also. So what I got to do is subtract 1.33 from both sides. So the first x is going to give me 2.19 minus 1.33. So I have approximately 0.86 as one answer, one root. And the other one's going to be a negative 2.19 minus 1.33. And that's going to give me an x equal to approximately negative 3.52. These are irrational numbers, and most of the time we're just going to have to round our numbers.